Hi everybody, this is Mark Washburn from PondAlgaeSolutions.com, and in this video I want to talk about how to deal with algae problems in large ponds. By our definition, large ponds are those that don't use mechanical filtration or biological filtration. They're a little too big for that kind of thing, and so you're basically dealing with these in more of a natural setting. And this is our step-by-step process or protocol for working with most of these ponds in working against algae growth. So the first step that we take whenever we're evaluating a pond, we want to accurately measure the size, volume of the pond usually, and this would be in a gallon measurement or an acre-feet measurement. We've got calculators on our site that can help you with this. If you know the dimensions, the general dimensions of the length, the width, and the average depth, you can punch those numbers in and it will kick out numbers relating to the gallon volume or the acre footage of that pond. Gallon volume is relatively easy to figure out. You can take the length in feet times the width in feet times the average depth in feet, multiply that number by 7.85 and it will give you a gallon volume. And some of the products that are used in the industry are dosed by gallons, others are dosed by acre feet, and so you'll want to know probably both of these somewhat accurately to begin working with your pond. Number two, you want to determine whether what you have in there is some form of algae or aquatic weeds. These are often treated somewhat differently, particularly in the category of weed growth. There's a variety of products that can be used. Some will not work on certain types, and others will work great, and so you want to be very targeted whenever you're applying something to try to improve the condition due to a problematic growth. So it's important to do a little bit of work and try to figure out what you have in there. There is a website from Texas A&M University called Aquaplant, which you can search for online, which will help identify what you have, and it also talks about management options too. So if you have algae, for example, and we're gonna this video will focus on algae primarily, you want to first of all look for nutrient sources, phosphates and nitrates that could be fostering this growth. Usually when you have algae problems in a pond, it's because of high nutrients, and unlike a small pond, some of the things that would affect a small pond simply will not affect a big pond that much, things like fish loading and such, because the volume is so much greater. But normally environmental factors will be a main cause of these kind of things, and so you want to look for nutrient sources such as fertilized runoff from surrounding ground. If you can figure out the source water, where is the source water coming to replenish this? If it's coming from upstream or underground and you live in a agricultural area, it's very likely that that source water is nutrient rich. You also want to consider muck and sludge buildup at the bottom, which is a big factor. If you get over the years a lot of leaf debris or dead algae or other material down there that's decaying and decomposing, it's much like compost in a garden. It's going to feed more growth at the surface, and so you want to try to figure out exactly where your main issues are. Number four, if you have aeration, you definitely want to use it consistently. If you don't have aeration installed, you want to consider it and investigate it. Aeration is a primer for maintaining the quality of a large pond, and it's instrumental in improving the condition if you have stagnant conditions, decaying conditions, things like that. Aeration alone may not turn an algae problem around, but it's a precursor to doing it in the most effective way, and there are cases where it alone can improve the condition so much that algae will begin to clear up. So making sure that you have a subsurface aeration system, that's one that's going to release air on the bottom, is probably the best way to go, and these are usually sized based on the depth and the area that you're trying to cover. And so you know, do a little research on this and see what's available for your size of pond, but it's a great first step to take in improving the condition overall. Also, it helps protect fish from unwanted oxygen depletions. Number 5, we would then look to add a beneficial bacteria, and there's various forms of this that we might want to use. If we know that there's a lot of muck buildup at the bottom, we may target that a little more with bacteria to try to reduce that down initially. We may use a pond-wide cleaning bacteria, but the key with any bacteria is, first of all, making sure that you use your measurements, your prior measurements of the pond size, and make sure that you're using enough. You would start with a minimum dosage matching, let's say, the gallon size of that pond or the acre footage of that pond. That's your baseline level. You also then need to consider how high your nutrient loads could be, and if you have high counts of algae growth, you want to probably use a significant amount more than what the dosage instructions might call for. We have often used in initial treatments as much as double the amount of recommended bacteria in the first couple months to make sure that we're not underdosing, because if you underdose, you'll probably get very limited changes or very poor results. And particularly if you don't have aeration and you're trying bacteria, you definitely need to use more rather than less. And also, you want to test the water ideally prior to use. Some simple test strips will be at least a good start, and what you're testing for is pH, alkalinity, and water hardness, and you want to see a reasonably neutral pH. Neutral being 7. You don't have to be perfect, but you should be somewhere probably between 6.5 to 8.5 to 9, somewhere in that range. If you're way out of that, bacteria may not work as well. You also need a little bit of mineralization in the water for it to work best, and so those are good things to check before you start on a routine. Now, we would add bacteria at the proper or adequate dose, and we would do this for 60 days. In whatever form you have to add the bacteria, whether it's bi-weekly or weekly or monthly, you want to run this program for about 60 days. Oftentimes in the first 30 days with good aeration, you may see changes in the algae. It may begin to regress, or it may turn colors or whatever. But you want to try to take the pond to clearing with the bacteria. And if you can do that, then at the end of 60 days, I usually stop. I don't necessarily keep going. I will test out whether I can discontinue the bacteria supplementation or whether I need to do it more. If you get clearing, you stop at 60 days, and then algae comes back, you know you've got a bit more work to do, and you would repeat the process of another 60 days, trying to maintain longevity between each period of treatments. But you're constantly testing to see, do I need to use bacteria or can I stop at this point? And it's much quicker to clear up a very small algae problem that may be showing up after a regimen of bacteria than it was the very first time around. It's that initial stage that takes a bit of time to get going, and this is not a quick fix treatment. It's something that, like I said, you might look for changes in the first 30 days, and we see it a lot of the times, but it may take longer than that. However, if I get out to 60, 90 days and beyond, I don't just continue adding bacteria with the hopes that things are going to turn around. I start to troubleshoot, and I look for reasons why I'm not getting the response that I am. In shallow ponds through this period, I may add something like an aquatic tinting dye, which comes in blue, black, blue, and blue, some color that you may prefer, particularly if the water is shallow, because the sun can play a major factor in that. I may also look to add barley straw or a barley type of a product in the mix, and certainly if I have heavy muck or sludge at the bottom, I may combine a pond-wide cleaner with a muck reduction bacteria. Oftentimes these are in a pellet form, and begin to work on both of these problems simultaneously. The importance of stacking these things into the mix is I guess can't be understated, because depending on what the pond's circumstances are, sometimes bacteria alone may need some additional help. If we go 60 days and we're not seeing improvements, before I discontinue bacteria regimens altogether, I would probably suggest trying another bacteria blend of some type, whatever you may prefer or what may sound good, only because some bacteria work better in some ponds than others. And if you have gotten a partial response through the first 60 days, then it could be a matter of dosage. It's more a matter of dosage or improving the conditions with aeration to try to improve this response. But if you haven't seen anything change, then normally I will look to change the bacteria blend and go another 60 days just to see if I can get some changes or movement in the right direction. In step 9, we might look at testing or doing some evaluations for using ultrasound technology in some of these ponds. Certain ponds set up very well for this. Some ponds respond exceptionally well to ultrasound. Much of it depends on the type of algae that are present in the pond. You still usually want to work on underlying conditions like nutrient levels, even with ultrasound in place, but oftentimes when we combine aeration, some limited bacterial supplementation, and ultrasound, we get a very good control measure out of that, and so ultrasound is worth looking at, and there are ways to test for it and its effectiveness in a particular pond, and so that's something to consider. Now step 10, if we've tried a number of different things and we're still not getting anywhere, we may look to use some type of an algicide. Algicides come in a lot of forms. Very traditional ones would be called copper sulfate or Cutrine plus, and generally we don't like to use those too much because they build up the copper levels in the pond, and particularly low in the pond, which we don't want. There are two that we use. One is a granulated peroxide, which is basically topically applied to the algae growth. I suggest these for spot control only because they're not as effective or efficient and cost effective, I guess is the word I would say, for dealing with very large blooms of algae on a pond. But they're great for spot control, and they don't hinder ongoing bacterial work, which is important, and so they're useful in that regard. We also use a low dose copper algicide that can be used to treat an existing bloom once, but the purpose of this algicide is to maintain a very low copper concentration in the water that you control, and it's designed to keep new algae from forming. This is a critical distinction compared to the old idea of treating a bloom, killing it, waiting, then treating another bloom, killing it, and waiting in this cycle, because if you go through this, you end up building up a lot of organic loading at the bottom of dead algae over a period of time, and this is something that really takes the pond in the wrong direction, and you don't want that. Ideally, you want to use something that will restrict algae growth from even forming out after an initial treatment. Also, there are now a few organic or enzyme-based muck reduction tools that can be combined with herbicides and with algicides, and I highly encourage people to use those, because again, if you are forced to use an algicide for some reason, you still want to keep the muck reduction going. You have to keep cleaning the pond up from the bottom up, and if you do that over time, you may end up reducing your need for treating with any kind of a chemical or any kind of product. If the muck is reduced to minimal numbers, then algae may not grow anyway. So you want to continue on with that important work. So this is our step-by-step protocol for dealing with algae in a large pond. In some degree, it doesn't matter whether it's green water or string algae. We sort of look at it in a similar way. We still want to reduce nutrient loads, and we still want to try to clean the pond up at a baseline level first, and we may use other technology to help with that, like ultrasound. Aeration is a key factor, but we don't distinguish too much between the two in large bodies of water. We hope this gives you some ideas that you can follow up with, and if you have any questions, let us know at pondalgaesolutions.com. Have a great day.